In this video, we're going to talk about vertical and horizontal asymptotes as well as holes of a rational function. These are going to be important for us to understand the behavior of the functions and also when we're discussing limits. So remember, a rational function is defined as a ratio of two polynomial functions is expressed as r of x is equal to p of x over q of x, where p of x and q of x are polynomials. So for vertical asymptotes, they're going to occur when the rational function approaches infinity, and this will happen if the denominator becomes 0 while the numerator does not at the same x value. And we'll talk more about that. So when we're finding vertical asymptotes, what we want to do is factor the numerator and denominator if they are not in factored form. And then we'll cancel any common terms in the numerator and denominator. And then any terms that are left over in the denominator, we're going to set those equal to 0 and solve for x. And then those values of x will let you know where the vertical asymptotes will occur. So let's take a look at an example. So for the first example, we have r of x is equal to x squared minus 4 over x squared minus 1. So we're going to go ahead and factor this. So in the numerator, we have a difference of 2 squares, so that's going to factor to x minus 2 times x plus 2, and the denominator is going to factor to x minus 1 and x plus 1. So we can see there's no common factors in the numerator and the denominator. So our next step would be to take each of the terms in the denominator and set them equal to 0. So x minus 1 is equal to 0, and x plus 1 is equal to 0. And then we'll go ahead and solve each of these. So on the left we have x is equal to 1. That'll be one of our asymptotes. And then on the right we have x is equal to negative 1. So that's our second asymptote. So if you went ahead and graph this, you would notice you have two vertical asymptotes, one at 1 and one at x equals negative 1. All right, let's take a look at another example, and if you want to give this a try, feel free to pause the video and then restart to see the solution. So first step would be to factor. In this case, we don't have to factor because the numerator doesn't factor and the denominator is already factored. So let's check for common factors. There are no common factors. Step 3, set the factors that are left in the denominator equal to 0 and solve for x. So we have x minus 2 is equal to 0, and x plus 5 is equal to 0, which means that our asymptotes are at 2 and negative 5. Okay, and in some other examples, we'll take a look at what it looks like if factors actually do cancel out. All right, moving on to horizontal asymptotes. Okay, so the horizontal asymptotes describe the function's behavior as x approaches infinity or negative infinity. So here's how we're going to find horizontal asymptotes. We're going to have p of x is the polynomial in the numerator, and q of x is the polynomial in the denominator. And so what we want to do is we want to compare the degree of the numerator to the degree of the denominator. So if the degree of p of x is less than the degree of q of x, then we have the asymptote y equals 0. Okay? If the degrees are equal, then our asymptote is y is equal to, and then we have the ratio of the leading coefficients. And then if the degree of p of x is greater than the degree of q of x, there's no horizontal asymptote, but there's possibly oblique asymptotes. And we're not really going to talk about oblique asymptotes. I'm just going to mention them here, that even though the degree of the numerator may be more than the degree of the denominator, there still may be these oblique asymptotes. So let's take a look at an example. In this example, we can see that the degree of the numerator is equal to the degree of the denominator. These are both 2. So then our horizontal asymptote is going to be the ratio of the coefficients, so 1 over 1, so we get y is equal to 1. Okay, and there would be some vertical asymptotes here, but we won't talk about them in this example. All right, example 2. Again, we're just looking for horizontal asymptotes, so we're just going to compare the degree of the numerator, which is 3, to the degree of the denominator, which is 2. So, since degree of numerator is greater than degree of denominator, there are no horizontal asymptotes. Okay, moving on. Again, anytime you want to pause and see if you can figure these out on your own and then restart the video to check, feel free. So for this one, the degree of the numerator is 3, the degree of the denominator is 4. Since the degree of the numerator is less than degree of denominator, our horizontal asymptote will be y equals 0. Okay, so pretty straightforward process, just looking for the degree of the numerator and denominator and comparing them. Now, let's take a look at holes. Holes appear where there is a common factor in the numerator and the denominator. So, steps to finding the holes. We're going to factor the numerator and denominator. Factor numerator and denominator. And then we'll identify and cancel common factors. And then we're going to solve for x from these common factors. And then substitute these x values into the simplified function for the whole coordinates. So it sounds complicated, it's not really. Let's take a look at an example. So for this first example, the numerator is going to factor to x plus 5 times x minus 1, and the denominator is the difference of t squared, so that'll factor to x plus 1 times x minus 1. Right, and we can see that I have a common factor, which I am going to cancel out. So if I solve this common factor by setting it equal to 0, so x minus 1 is equal to 0, so x is equal to 1, that means that the x coordinate of this whole is going to be at 1. So if I take this and I plug it back into whatever is left here, I'm going to plug it back into that. That means that our y coordinate is going to be 1 plus 5 over 1 plus 1, which is 6 over 2, or 3, which means that we have a whole at 1, 3. All right, let's go ahead and take a look at asymptotes. So for vertical asymptotes, the factor that's left in the denominator is x plus 1, so we'll set that equal to 0, which means that x equals negative 1 is a vertical asymptote. And then for our horizontal asymptotes, let's look at the original function here. The degrees are the same here, 2 and 2. So we're going to have y equals 1 for our horizontal asymptote. So there's our whole, there's our vertical asymptote, and there's our horizontal asymptote. Okay, one more example here. Find the asymptotes and holes. So again, this is already factored, so we don't need to do that step. And then these factors are common, so they're going to cancel out. So let's start with the whole. So x minus 3 is equal to 0, which means that the whole is at x equals 3. So we'll substitute that back into what's left here, which is x plus 4. So the y-coordinate is going to be 3 plus 4, which is 7. So our whole is at 3, 7. Okay, vertical asymptotes. No functions left, or no factors left in the denominator, which means that there are none for vertical asymptotes. And then the degree of the numerator for our horizontal asymptotes, the degree of the numerator is actually 2. So if I distribute it in the numerator, I would have x squared plus x minus 12, and in the denominator I have x minus 3. So the degree of the numerator is greater than the degree of the denominator, which means there are also no horizontal asymptotes. Okay, and just to mention it, oblique asymptotes, if the degree of p of x is 1 greater than q of x, we can find the oblique asymptote, which would be a line, by performing polynomial long division of p of x by q of x. Okay, and then you just disregard any remainder, and the quotient represents the oblique asymptote. So we're not really going to talk about this further than mentioning it here. Just something interesting. Okay, if you have questions, make sure you ask, and we'll see you in the next video.